Morning. This is Wednesday, May 6th. It's our final month of schooling for this year. I think a lot of us are ready to get this year done with, move on, and become seventh graders next year. Because it's been kind of a tough and weird year. This is my joke for the day. I stole this off somewhere on the interwebs, and it's a bunch of division signs, and the little kid division sign says remainders again. I guess that's kind of like leftovers in the division world, huh? Okay, so I don't know if that's that funny or not, but it's kind of a funny in the math world. This is on tap for today's math homework. This is in addition to if you're doing Freckle or the Math Minutes. Something I'm noticing on Freckle, don't admit to this, but I know that a lot of sixth graders are logging into Freckle and doing the fact practice for about 10 questions worth or 9 questions worth, and you're getting about 1 to 2 minutes worth of work, and you're getting good scores, and that's good. But then you're just done. And I think you're just checking that off the list to say, hey, I did Freckle today, Mom. And that's not really the point of it. The use of Freckle is not to review things that you already know. It's to work through. Well, it is to review some things, but it's not to continually do the same thing that you're already good at. You're not learning. You're not moving forward from that. So Freckle fact practice is not necessarily as beneficial as the Freckle assignments that are in there, like the adaptive practice, or I even put some science ones in there too. Also, the afternoon class did not ever do a survey based on the Apollo missions unit that we did. We did 3 or 4 lessons from the Apollo missions, and then we talked about the different things on the display. And we need it's kind of like a post test. It's basically a survey, Google form that I'm going to send out to the afternoon class. The morning class already did one, but the afternoon class needs to do that. And it's not something that I want you to ignore. I want you to do it because there's some people working on their master's degree developing lessons using that Apollo platform to just get better at how they're doing that. They're studying what they're doing. So they need your data, your information. It's not tied to your name in any way, so you don't have to worry about that. But I do want you to do your best as far as like what you remember and things like that. And then you can forget about it after you've done it. So I'll be sending that out to the afternoon class probably today or tomorrow. Okay, to the work today. This geometry quiz, this is basically stuff you can Google, but it's good to match the vocabulary word with its picture over here. That answer to number 1 is not even showing on there yet. It's down at the bottom of the page. I don't think you're going to have much trouble with this. I think everything's going to be pretty easy, and I doubt you have to Google much. But number 2, the plane, we should probably talk about that real quick. I'm not sure we talked about that much. Plane is kind of like if you imagine a piece of paper that goes on forever. It's the biggest piece of paper in the universe. That would be what a plane is, but it can't bend or flop or anything like that, because that makes a plane no longer a plane. A plane needs to go only 2 directions. Let's see if I can get to the corner. Here and here, and it goes on and on forever. And you can't represent that on paper without using arrows, which means it goes on and on forever. So a plane is a 2-dimensional object that goes on and on forever. You can think about that term's used often in phrases like on this plane of existence, or on a level plane, or a level playing field. That's different too. But a plane is basically a slice of the world, or of the universe. Okay, it's hard to define that, but you can match it up with the image that I showed you there. A couple of the other ones involve circles, and so we're going to spend just a couple minutes here talking about the circle. And I know that since you've been in kindergarten, everybody's an expert on circles, but we need to talk about the vocabulary of it. Now, I drew this circle just ahead of time, but I just basically used a coaster. There are things like compasses, and I have a safety compass in my room, or safety compasses, you've probably seen those, that you can use to draw a circle. Most of the time, if you use a coaster or a cup or any kind of lid, you can draw a fairly neat circle. Problem is finding the center. But so I estimated this one. I think it looks pretty close. If you use if you use a compass, then the circle is easier to find because you've already put a dot there. You start with the center and you rotate it out and around. Okay, so this is a basic circle. We've already talked a little bit about how the perimeter of a circle is its circumference. And so when I'm giving notes, I like to draw this out and put circumference along the outside. Sometimes we do it wider so it looks like it actually follows the whole thing. The circumference is the distance around the outside, or it's defined as the distance from one point following the curve of the circle all the way to that same point. It's the distance between one point. That only works on a circle. Okay. If you happen to have from one of those points on the circle. By the way, a circle is defined by all the points equidistant, which means the same distance from a center point. So if you're looking at this and you're thinking, okay, here's this point, this point, this point, this point, this point, and every point in between, all of those points are actually what defines a circle. It's weird to think about it as points when we draw a line to do it, but geometry, a line is just a straight mark, and in this case, a circle is defined as points. Okay, so if I was to draw a line from that point on the outside of the circle to the center, that's called a radius. Okay, we've talked about that before. If you have many of them, several of them, you talk about the radii. If you happen to go all the way across, in this case, I'm going to go up here and do all the way across at a different angle. I got to keep my ruler straight through the center from one side of the circle to the other. That's called a diameter, and it goes all the way across. Endpoint and endpoints are on the outside of the circle. Okay, this is called the center. We've talked about that already. I've mentioned it several times. I should probably label that center. A little bit later, we'll talk about how to name a circle, and when you name a circle, it's based on that point right there. That's the center. Okay, so we've got a radius, we've got a diameter, we've got our center and their circumference. To find the area, you would shade it all in, and you're going to use pi for that. We'll talk more about that in 7th grade and 8th grade. I think it's more 8th grade than 7th grade with circles. So we've got most of these things taken care of. Sometimes, though, you have to worry about a line that's on the outside of the circle that goes from one point on the circle to another point, but doesn't go through the center. So the line that I'm drawing here didn't do a very good job matching my point. The line that I drew there from point to point is actually called a chord. I know we've visited that through Math Minute before. And when I write it up there and don't pronounce it, everybody says chord, but it's a chord spelled with a CH. And that's another part of the circle. There is this part right here can be defined. This, from this point to this point, following the curve, is called an arc. That's a geometric term, ARC. I shouldn't write so small when I'm trying to do this on a small screen. And I think that's pretty much the information that we needed for a circle. You don't have this paper in your packet. I don't believe you have this paper in your packet. If you do, I'm about to surprise you by doing almost all of it. There's a couple questions here. Construct a circle with a radius of 1.5 inches. That's real easy to do, especially if you have a compass. It's not that easy if you don't, but you measure out the 1.5. So here's our 0 mark. Here's 1. Here's 5. 1.5 inches. And you draw a circle from this point to this point. And I don't have a compass here at home. I didn't bring one from school either. But basically what it is it's two sides. One is usually a point and one's a writing utensil, usually a pencil. And they're connected at the top where they're not flip-floppy. And you can set them at an exact distance. And then when they're joined in the center, you can turn them, and you basically turn one around the circle and pivot it through there. So you're not going to get to see that today, but I think you've probably seen that before. Construct a circle with a 3-inch diameter. Well, actually, the trick to this is it's exactly the same one, because if this is the radius where it's only half of it, the diameter would be double that, right? It would actually be the same circle drawn twice. Okay? Now, you're given a circle down here at the bottom of this page, and I'm getting a weird message that says the USB is not working, but I think we can see fine here, so we'll just keep going. Name the circle. So here's our circle, giant circle here, and our center point is A. That's all you do is you call it circle A or circle A, or you could just A. Okay. Name the center. Well, that's easy. It's already A. Name the chords. Remember, chords are the lines that go through the on a triangle, or sorry, on a circle that are on 2 points, but they don't go through the center. Actually, that's not true. A chord or a diameter is a chord. It goes from 2 points. It doesn't have to go through the center to be a chord, but one that does is. So that changes our answer here. So the chords here are B and C. So remember how we do line segment BC. Then you're going to have line segment EC. It doesn't matter what order you do. And BE, because that goes to 2 points. And those are the only 3 points on the outside, except this one. But that's not a chord, that's a radius. So I have to make sure I've got all these 3 BC, including the diameter, which is a chord. About forgot to tell you that. And but it's a special one. So that's EC, which is the diameter. All 3 radii. Now, those all start at the center, so you've got a line here, and a line here. So that would be line segment AC, line segment AD, and line segment AE. All of them starting with A because they all start from the center. Okay? Name 3 central angles. So these are the central angles. They're at the center. 1, 2, and this one here. And label each as obtuse, acute, or straight. So back to that naming of angles thing. Let's start with this one here. E, A, D. You don't have to put them in alphabetical order, but that's a lot of people do that. But you do have to have this in the center, so that kind of messes things up a little bit. If you were alphabetical order according to geometry, it'd be D, A, E, because A has to be in the center. But we'll go ahead and do E, A, D, and that angle is it 90 degrees? No, it's less than 90 degrees, so it is an acute angle. Okay, then we have this one over here, C, A, D, or D, A, C, same angle. We can do whichever one we want. And it is greater than 90. If it's going straight perpendicular to this line here, that would be 90, and we have 2 right angles. But this one has an acute and an obtuse. This is our obtuse. And then we've already kind of talked about it. This is an angle around the A, and that's EAC, angle EAC, which is a straight angle. Just by telling you that, instead of saying classify the angle, they gave you the 3 option, and you kind of knew that there was going to be a straight. Okay? All right, so that's basically the lesson for today. There is one problem on there, if you have it, that I wanted to look at with you, because we didn't talk about this much this year. It's more of a, I don't know if that falls in 6th grade. You probably see it on Freckle as you go through there. It's these 3 vocabulary words: translation, rotation, or reflection. Those are the ways that things move on a coordinate plane. There's that word again, plane. And these are the relationships of how they move. So the first one, where you've got the 2 triangles, that triangle has basically, from the first one, it just flipped over, right? It's like there was a mirror right between there. Well, what do we call that when you see your reflection in a mirror? So that one is reflection. And then this one, to get from this one to this one, you kind of just looped it down, right? It's like you had a pivot point right up here, and you nailed it to the wall, and gravity just flung it down, right? That's what you call rotation. It rotated around this point, a pivot. When you pivot in basketball, you put your foot down, and you move your body and everything else around that one point that you've chosen as your pivot point. That's a rotation, so you rotate around that. Here, this is the same triangle twice. The only thing is it's moved its location. And whenever it just moves location, it doesn't change shape or size, doesn't reflect. That's just called a translation. It's just moved from one place to another. Now, technically, you could talk about this being a translation, because it's not drawn right over the same one here. It would have been moved, but that's whenever you do one of these, they take precedence over that translation. So if you can't find that it's a reflection or a rotation, it's almost always a translation. Okay. And then on the bottom, there's the thing that says corresponding angles. Corresponding means to match up, right? So what they're asking there is, like, angle ABC, which is this angle right here, ABC, corresponds to which one? Well, you start at the bottom, go up to the corner of the right angle, and then you go across. Start at the bottom, go up to the corner, and start across. This angle corresponds to this angle. So these are what they call similar triangles. They're not the same size, but they're the same shape. And so similar triangles have corresponding angles, and that's what they're trying to point out here. Angle ABC corresponds to angle D, E, and F. Okay, I don't think that will be too hard for you. These down here are line segments. They don't have the line segment thing over that because that's hard to type. But that should be pretty simple for you. As always, email me if you have any questions, or if you just need to talk about something. It's kind of fun to get your emails and read them. I may not always respond immediately if it's in the afternoon or different time of day, evening, because I hold to my office hours in the morning, but in the afternoon, sometimes I've got other things that I'm working on, and don't pay as close attention to my email. Anyway, hope you guys are doing okay. Let's talk if you're not.